In this video, we're going to go over inequalities in two triangles. So we're going to start off with our hinge theorem, which is our side angle side inequality theorem. So in this theorem, we will have if two sides of a triangle are congruent to the sides of another triangle, and the included angles are not congruent, then the longer side is going to be opposite the larger included angle. Okay, so for example, just kind of looking at what we have off to the side here, let's say we knew that the measure of angle A was greater than the measure of angle D. Well, then that would lead that the side opposite of that angle A, so that side BC, would be larger than the side opposite of that angle D, which is that EF. Okay, then we have our converse to that theorem, which is our side inequality. And so in this one here, if two sides of one angle are congruent to the sides of another triangle, and the third sides are not congruent, then the larger included angle is going to be opposite the larger third side. Okay, so in this case, if we happen to know that the length of segment BC is larger than EF, then we can say that the angles opposite of those two sides, so angle A and angle D, then we can say that that measure of angle A will be larger than the measure of angle D. Okay, so let's look at some practice problems down below. Okay, and they're asking us to refer to each figure to write an inequality relating the given pair of angle or segment measures. All right, so for number one, we're just trying to figure out what we can determine about the measures of these two angles here, angle 1 and angle 2. Well, we notice that on either side, we have that these two sides are 12, so they're congruent. And then something else that's kind of sticking out is the fact that we do have these two 65-degree angles. And so this is going to be an isosceles triangle here, and so we can say that these two sides here are congruent. So it looks like we're going to have that converse of our hinge theorem because we then know the third side. We know that the 7 here is larger than my 6. Therefore, the angles opposite of those, so the angle opposite of my 7 is going to be that angle 2, should be larger than the angle 1 that's opposite that 6. Okay, now let's look at number 2. So in number 2, once again, we do have our isosceles triangle. Okay, so I got these two 50-degree angles, which means that these two sides here are congruent. Then we see that they both have these 25 length sides. And this one is going to be using that hinge theorem, the side angle side, because here we'll see that that 35 degrees is larger than that 30. Okay, so these two angles here. So therefore, my side opposite that 35, which is EB, should be larger than AD. Okay, in number 3, we've got UT and TS. So looking at what we currently have, we have our side lengths of 12 are going to be congruent. Then we have that lovely reflexive property, that shared side, which gives us our second congruency. And then we are dealing with the angle measures. So we're going to have that side angle, side one. And we'll see that 22 is larger than my 21. So the side opposite my 22, which is UT, should be larger than the side opposite of that 21, which is TS. Okay, in number 4, we have given to us that the 6 is going to be congruent. Then we've got that reflexive property, okay? And then I will see that one of my side lengths has a length of 8, and then we got that length of 5. So the angle opposite of my 8, which is going to be this angle here, which is LPM. So LPM, that's that first one, is going to be larger than the measure of my angle MPN. Okay, now let's look at some problems that will kind of go back to our previous inequalities in triangles lesson. So using the figure, we're going to answer the following. We're going to find the shortest and longest segment in my triangle DEG. Okay, so I'm going to start off with, we'll say my shortest. And then we'll fill in the longest here. All right, so let's look at triangle DEG. So DEG, that's going to be this triangle here. Okay, so we are going to see that 50 degrees is my smallest angle, so my side opposite of that is going to be that EG. So that's going to be my smallest. Then my longest is going to be across from that 70 degrees because that 70 degrees is the largest one for my angle measures, and that's going to be DE. Okay, now let's look at the next one. We've got find the shortest and the longest segment in my triangle EFG. So we're going to just write it out real quick. All right, so my shortest one, we're looking at this triangle here. We'll see that the shortest should be opposite my smallest angle, which is going to be that 40 degrees. Okay, so that means that GF is going to be my shortest one. And then my longest, we've got my largest is going to be that 80 degrees. So opposite of that is that GE. So that's my longest in triangle EFG. Okay, now let's move into the last part of that question. We got the shortest and the longest segment in the figure. Okay, so I'm going to just one more time write out my shortest and then my longest. Okay, so looking at it, since we have that shared side, we can see that my shortest in this purple triangle, remember, is going to be that GE. But if we look across from it into the other triangle, we see that that's the 80 degrees. So that means that it is going to be the shortest in the purple, but it's the largest in the blue. And so then we want to look even smaller than that, which would be opposite of my 40. Okay, so opposite of that 40 degrees is going to be GF, and that will be my shortest in the entire figure. Okay, then for my longest, okay, we'll start in that one. We've got my 80 degrees overall is the biggest angle. And so in that blue triangle, my 80 degrees is opposite of that GE, But if I look in my purple, I see that it's the smallest. It's opposite my 50. So I need to look opposite of the 70, which is the largest angle in that triangle. And so that's going to be my segment DE. Another way that's for some of y'all might be a little more helpful is if you write it out, just using the side lengths in general. So for my purple triangle, I would have my shortest one would be that GE. Then we would have the next one would be DG. And then the longest one would be that DE. Okay, then moving into my teal one, we've got the smallest one would be that GF. Then we get larger with that EF. And then my largest one would be that GE. Okay, so now kind of looking at what we have here, we can see that they have in common that GE. And this will allow me to kind of tie them all together. So that allows me to see that the largest side overall is going to be that DE. And then my smallest one would be that GF. Okay, so now let's look at our last two problems. And so for these, we're going to write an inequality or pair of inequalities to describe the possible values of x. Okay, so looking at what we have here, okay, we see our sides are going to be congruent here. We got 12 and 12. Then we have that reflexive property, okay, that will allow me to say that since this side here, this 11 is larger than my 10, then I know that that 42 degrees should be larger than that 3x minus 18. Okay, something else that we want to kind of think about is the fact that this right here is just telling me that it can be less than that 42, but I need to consider the fact that we shouldn't have any negative angles. And so therefore, to fix that, I need to make sure that I'm also saying that it has to be larger than 0. Okay, so that way we don't have any negatives. Then I'm just going to go through and solve for my x here. Okay, so I'm going to add that 18 to both sides. So 42 plus 18 is going to give me 60. And then that 0 plus that 18 is just going to give me 18. Then I'm going to go through and divide all of them by 3. And so when I divide that 60 by 3, I'm left with 20. I'll have my x, and then I'll have 6 over here. Okay, so my final answer here, and it doesn't really matter as long as your signs are correct, is just going to be that my x is going to be greater than 6, but it is less than 20. Okay, so that's it for number 6. With number 7, I will say number 7 is going to be a little bit more challenging. Okay, so we have that reflexive property here that says those two sides are congruent. Then we've got our sides of 20 that are congruent. And then I notice here that my 110 degree angle is larger than that 100 degree angle. And so therefore I know that that 5x minus 7 is going to be larger than my 28. Okay, so take a second, let me write that down. Okay, but with that being said, we need to keep in mind that when you add two sides of a triangle, it should be larger than the third. And so right now we currently know that since this is my obtuse angle in my obtuse triangle, that side is the largest one, but that when we add my two sides, okay, this side here and this side over here, we want them to be greater than that 5x minus 7. And so on the other side, I'm going to kind of set that up with that. But since I don't know this side here, I'm going to label it y. We're going to say that y plus that 20 should be greater than my 5x minus 7, which will then be greater than the 28. Okay. So now that I have that in there, I need to go through and I'm going to solve for that x, okay? And so doing that, I'm going to add that 7 to both sides. So I'm going to get y plus 27 is greater than my 5x, which is going to be greater than my 35 that I get when I add that 7 to the 28. And then I'm going to divide everything by 5. So over here, I'm going to go ahead and just leave it as 1/5 y plus 27 is greater than my x, which is going to be greater than 7. Okay, so something we need to consider here is, what is y? Well, we're going to have to set up an inequality for what the possibility of what y could be. And so we are going to kind of talk about a little bit of what we did in this one here. So y, we obviously know it's going to be less than, okay, it's going to be less than that 28. Okay, and just to clarify why, it's going to be because we have that obtuse angle here, that 100, which is directly across from that 28, which means since that is the largest angle, the largest side we could possibly have in this triangle is 28. But on the other side, okay, we've got to figure out what is kind of the lowest point that we could get. Well, remember, your two sides should add up to be larger than your third side. And so here, that 20 plus y, we want it to be greater than 28. Okay, so that means what I can do is I can take that 28 minus 20. Okay, so that 28 minus 20 tells me that this side here, my y, has to be greater than 8, but less than that 28. Okay, because think about it. 20 plus 8 gives me 28. That means it's no longer a triangle because it's not going to be greater than that third side. But, you know, we're saying it just has to be greater than 8, which could give you that 8.1. So 20 plus 8.1 will give me 28.1, which, yes, is greater than the 28 that we need it to be. Okay, so when we're writing this inequality, because we do have that other variable in here, we've got to mention that y, so where y is going to be greater than 8, but less than that 28. Okay, and so this right here would be my final answer for this problem.